Good afternoon, everybody. Here we are for the final session here in the theater this afternoon, SSL Break and Inspect. The session's been approved for CompTIA and GAC continuing education credits. So if you're an AFCEA member, if you'd like to receive documentation, come visit us here after the end of the break and have your badge scanned. If you're not a member, you can join today here at the AFCEA booth right across the aisle. Presenter this afternoon is Mr. Paul Deacon, Senior Systems Engineer for F5 Networks, and I'll turn it over to him now.
Now? I don't like this. All right, so I'm going to talk about SSL today, and I think he introduced it as SSL Break and Inspect. I've just changed the title to SSL Inspection because I don't like using the word break in the title, because we don't break SSL, we actually enhance the SSL, or how you deploy SSL with F5. So today, is everybody hands up? Hopefully everybody's heard of SSL. Okay, good. Every time you go to your bank, you're using an SSL connection, right? So I'm going to talk a little bit about SSL, some SSL best practices. You might think it's really easy just to turn on and use, but it's there's lots of ways to misconfigure it so that you can have connections that aren't very secure at all. And there's also ways that you can look at connections for users. We're going to roughly kind of categorize the types of connections as users from the outside of a network coming in to a network, which is what we would call a reverse proxy type of capability. And we're also going to talk about users from the inside going out. That's what we would call a forward proxy capability, and we're going to see all the different architectures or some of the different ways that F5 can help you in those types of deployments. Right. This is the Sidejack Cafe. So the whole idea behind SSL, right, is your user over here. Does this point? The user on the left is making an SSL connection on the right, and you've got eavesdroppers, right? And the whole idea behind SSL is you're trying to prevent the eavesdropper from looking at your connections. Now, has anybody ever heard of anything, a product called Firesheep? From about 6 years ago, there was a product called Firesheep that you could go into an airport. It was only out for a couple of weeks, but you could go into any airport and steal people's session information, and it was an attack that was launched against Hotmail. So you could use this app, grab people's session token, and use that session token to be able to get into the application. So read other people's email. I never tried it. Apparently, you could do it. The whole idea behind that was that they would encrypt the login piece of the SSL connection was done over HTTPS. The session information was actually returned over HTTP, so it was in clear text. So it allowed somebody who was on a network to be able to grab the session information. Microsoft was able to fix that really quickly. There's also a lot of things around SSL. I work for a company called Rainbow Technologies. Has anybody ever heard of Rainbow Technologies? So we got our start in the 90s making SSL acceleration cards, and we had a card that went at 50 transactions per second. You'd stick it in a web server. But that was back in the day when SSL negotiations took up a lot of CPU, right? So it was kind of an offload, a CPU offload coprocessor. But as time's gone on, kind of the whole idea behind SSL and the CPU, it's less CPU, or there's so much more computing power out there that SSL kind of offload is not as important as it once was. but there's so many things that, in terms of how you can misconfigure SSL. And say you have 40 different applications out there, you could have 40 different SSL configurations. So the whole idea behind centralizing your SSL configuration is to have one really good place to standardize on the way that you deploy SSL. So what we're recommending here is encrypt everything, right? We've got a solution that can support, we've got very high performance that scales to the number of the number of applications that you need, and it's one central place where you can manage all of your SSL connections. And we have solutions that can be deployed locally, and I know the Air Force is starting to look at the cloud as well, so we've got solutions that can also be deployed out in the cloud. Okay, so SSL is becoming more used, right? So when I first started doing SSL, there were only the basic websites, the banks were starting to use SSL. Amazon to buy your books at the time, before it became the Walmart of the internet. They were starting to use encryption, but people are starting to use encryption now to actually properly authenticate the user as well as the web server to the application. So it's becoming more and more prevalent, and people are trying to make their connections as private as possible. So you're seeing this huge uptick in the amount of SSL that's being deployed out there. There is the thing on the far right, I'm not even apparently supposed to mention that name. So there's the Welsh mountain. There's actually a Welsh mountain in North Wales called Snowdon. But yeah, anyway, that's why people are starting to wanting to encrypt and also look at what people are looking at going inside and outside of networks. So there's a huge uptick in SSL. This is a quote from Gartner. People are spending lots more on SSL. Okay. So the thing with SSL is it's made out of software and it's buggy. Has anybody? I think there's all of these vulnerabilities have come out over time, but as time has gone on, probably every 6 months to a year, there are new vulnerabilities that come out, and the latest one, or the one that I'm not sure if it's even the latest one right now, but the one that was the most publicized that I can remember is Heartbleed. Does anybody know what Heartbleed was? Has anybody heard of Heartbleed? Okay. So yeah, Heartbleed was a memory leak that allowed you to potentially capture information that was in memory on the host computer, and it could potentially there were some tools out there that allowed you to potentially capture the private key if it was loaded into memory on the host. So it's a very widely publicized defect, and patches came out fairly rapidly after it was released. But people, there's a little bit of hyperbole in there, but they're saying it's the end of the internet as we know it. I don't really think that that's true. That stuff was patched probably 2 or 3 months afterwards, but there probably are still servers out there that have that vulnerability. But all this says is that you need to stay up to date. You need to constantly be looking at all of the vulnerabilities that are coming out and make sure that your systems are patched and or secured to implement the SSL with best practices and with the latest stacks. If you centralize your deployment of SSL, so if you put something in the middle, like a proxy, you can centralize all the configuration of your SSL in one place to where you can have all of your different applications can have one place where you can configure SSL for best practices. Oh yeah, sure. So that was the Beast vulnerability. I don't know all of the vulnerabilities out there, but what they're saying in this case is it was a vulnerability that was related to TLS 1.0, and there are all these new versions of TLS that have come out. And in order to mitigate that, you needed to go up to later versions of TLS. TLS 1.2 was published in 2008. And we advocate for people to secure all their servers up to TLS 1.2, and also to enable something called perfect forward secrecy with SSL. What that means with perfect forward secrecy, you used to be able to, if you grab the private keys from a website, you used to be able to decrypt the whole conversations, or all the conversations that had ever happened with those private keys. With the addition of perfect forward secrecy, you can have distinct sessions, which make it much more difficult. If you captured the private keys, you still wouldn't be able to decrypt all of the conversations that had ever happened, because they have these separate session keys that are much harder to decrypt. So that's what Beast was, and the solution was to go up to TLS 1.2. There's one here as well that I can mention. Freak was factorizing RSA encryption. So when I first started doing this, we're deploying 512-bit keys, right? Computing power has increased. You can now pretty much with about $100 worth of cloud computing resources, you can actually factorize fairly easily a 512-bit SSL connection. So yeah, that's not really a vulnerability. It's just the fact that computing power is increasing so much, and we're recommending that you go up to things like 2048-bit keys. When 10 years ago, I was implementing with 1024-bit keys, and we're now pushing 2048 and higher for SSL connections. So it's a bit of a minefield generally. So there's, if you pick up a book, there's a book by Ivan Ristic about SSL. It's about 600 pages. It's a thriller. Like, don't use sleeping pills. Buy this book. But there's all these different things that you have to know around just implementation. And what we at F5 try and do is help you along the way towards deploying SSL in the best way that it can be deployed. Right, so hands up who has a cat card. All right. I don't have one. I've got some test ones. All right, so with PK enablement, this is a DoD mandate for PK enabling applications. So in your particular case, you have to use mutual SSL authentication. What that means is, instead of using a username and password, you're going to be using your cat card to authenticate to an application. And this is a chart. All of those different types of data with the green stars on it, they're the ones that mandate the use of a cat card. And F5 has solutions where we can CAC enable your applications. We have a DISA document, a published DISA document on DISA paper that shows you how you can use an F5 to implement CAC authentication and also single sign-on with F5 products. All right, a little bit about cryptography. On your CAC card is a digital certificate. It also has a private key and a public key. If I want to send you a message, I encrypt it with your public key, and then I send it to you. And then you can decrypt it with your private key. Make sense? And only that public key and that private key, they're related to each other. So if I encrypt it with that public key, no other private key can decrypt the information. The same is with digital signatures, right? So digital signatures are the ability for you to sign something, sign an email that says, okay, it's me, right? So you sign with your private key, and then you verify with your public key. So if I want to send an email to you, what was your name? Carruthers? If I want to send an email to Carruthers, I would sign and I wanted to prove that I had written the email and only me. I would sign the email with my private key, and then I would encrypt it with Carruthers' public key, send it to him, and he would verify it with my public key and decrypt it with his private key. So that's kind of the basic idea behind all these cat cards here. Anybody heard of these guys? I think this was has everybody heard of the SQL injection attack? So you have, yeah. That's my healthcare provider. So I got 2 years of free credit reporting for that. Yeah, that too. But yeah, so there's a lot of the things that people are trying to do. It's not particularly about SSL, right? It's about what's inside the connection, right? So I can set up an SSL connection to a server, and then I can try and do nasty things to the server. There's a group out there called the Open Web Application Security Project, and they publish like a list of top 10 vulnerabilities every year. Every 3 years, they're going to come out with one this year. The number one vulnerability is SQL injection. Still, somebody forming a SQL injection attack over SSL. Now, if I send that over an SSL connection and a firewall sees it, what will happen? The firewall will just allow the traffic in. But what you need to be able to do is to be able to look at that traffic and decide whether it's a SQL injection attack. So that's kind of the whole idea behind SSL inspection. There was one last year. There was a telecom company in the UK where there was a kid in Belfast, guy over there, 17-year-old kid, right? In his bedroom, managed to download the database with all the customer information. SQL injection attack over SSL. Anyway, some of the mitigating factors, and I wish we could all do this, but if I got a smart card if I got my bank to issue smart cards, that would be nice. So two-factor authentication, that's kind of a key thing, right? To be able to prevent these kinds of attacks. And also being able to look at the decrypted traffic with something called a web application firewall. Have you heard of a web application firewall? Basically, what that does, let's just say hypothetically you had a DoD application and you're using CAC authentication. You'd authenticate to the server with your CAC card. Then we would decrypt the connection, but then we would parse all of the decrypted traffic and be able to look at that traffic for threats. Again, things like SQL injection attacks, things like exfiltration of information. So we could look at information going outbound as well, saying, okay, well, it's a social security number. Let's redact the social security number from the stream. So a web application firewall implements or has the ability to look at all of that decrypted traffic and decide whether it's a denial of service attack or a vulnerability that somebody's running against your web server. All right, so we are widely deployed from a PK enablement perspective, and these are kind of some of the applications that we support. So it's all of the above. It doesn't have to be these, right? It could be a bespoke application that you developed, something that was specific to your missions, but we have integration guides for all of these things, including things like Office 365, all of the Microsoft applications. We publish these things called IAPs. And what IAPs do, it basically enables you to configure an F5 box to use or to sit in front of these applications and secure them, and also help with some of the authentication problems that would be specific to a DoD environment, like CAT card enablement, things like that. I've already done this one with Carruthers, but the whole idea behind, sorry, I'm not trying to pick on you, but the whole idea, right? You get you've got a DoD certificate authority, and they issue certificates to the web servers as well as to your CAT cards, and they're trusted by the fact that they're signed by a trusted root certificate authority, which is DoD certificate authority. So in order for that SSL connection to happen, the web server must authenticate itself with the user, and the user must authenticate itself with the web server. So it's the best, they call it mutual authentication, mutual SSL authentication. It's the best kind of authentication that we know how to do as yet. And it's very hard to get into that connection. It's very hard to, we don't really know how to, say, do a man in the middle with a mutually authenticated SSL connection yet, if it's set up with TLS 1.2. TLS 1.3 is going to come out this year as well, we think. Or somebody told me that yesterday. So these are your CAT cards. This is what might be in a CAT card. Has anybody actually ever looked at their certificate? Oh, really? I make them, not these ones. I have my own homemade CA. But yeah, but these are the sort of standard information. It's got an expiration date. We would also typically validate, in our implementations, we would take that certificate and do an OCSP check on it before we decided that it was a good certificate. So there's something called a certificate revocation list that you could use, but with the DoD they use something called an OCSP, which is an online certificate check. They check whether that certificate is valid and in date. And then we can also take the user, Big Bad Bob, with his EDIPI number, and then we could look him up in the directory and identify him, and then we might be able to do some single sign-on to the application on the back end. So that might look like a SAML authentication, or it might look like a Kerberos type of authentication. It's exciting stuff again. So yeah, this is our approach. So this is without F5. With F5, we sit there as a proxy, and so we host certificates for websites or services that we deploy on the big IP, and then we require users to authenticate with a smart card on the to the big IP. They don't have to be smart cards. They could be soft certificates that are installed on a phone, right? So I don't know. Some people are looking at things like derived credentials for phones. So that's where you can issue yourself with a temporary certificate on your phone, and that can authenticate you to the application. But what it would require you to have to do is go to a machine where you have a CAT card reader, log in, and then it would issue you a certificate to your device that would last for 2 weeks or some short period of time, and then you could use that certificate to authenticate to the server. We also do single sign-on as well. So once you've authenticated to the big IP, what happens then, right? So what happens? How do I identify the user to the application? So there are modules that are built into the big IP that allow you to do different kinds of single sign-on. I've mentioned SAML and Kerberos because those are kind of SAML's kind of the SSO of the moment. Also, the big IP that you don't have, your resources don't have to be in the same data center. So you could have a deployment where you're doing something called federation, where your big IP could be in Seattle. We've got a big IP in Seattle. I log into it, but then I've got full access to a number of cloud-based applications for my travel and all that kind of thing. And they're hosted by the companies that have those applications. Now I'll move on. So I've been talking about inbound use cases, but we think these are the kind of the three pillars of SSL. F5 has something called an HSM built onto the product. It has a FIPS certification. And it allows you to generate cryptographic keys on the box such that when you're using them for SSL authentication, they are never loaded into host memory. They're also tamper active as well, so that if you try and attack the box, the keys will zeroize on the big IP. So we have a hardware security module kind of built onto the box itself. And we also support some of these people, because if in large organizations you want to do key management, so we support third-party key management systems like Venafi and Symantec have a product out there as well, but that provides you the ability to kind of have a single pane of glass for all of the keys that you might have throughout your network. You don't have to use the HSM on the big IP. We issue big IP can be deployed as a virtual machine as well. So we support most of the hypervisors out there, and we support the ability to be able to use a network hardware security module by something like SafeNet or Thales. That's where the keys are kind of stored on the network, and your VE, your virtual edition running in VMware would make use of those keys by talking to the HSMs that are network attached. All right, has anybody seen this? So Qualys have a website where you can go out there. You have to seek permission from the people that you want to test the website against. I don't know. Technically, it's illegal if you do this, but it allows you to put in a website and kind of you get a grade on. They give you a grade as to whether you're implementing the SSL best practices or not. We have a guide that shows you how to get an A grade if you're using a big IP. It's all about using the latest version of TLS, using the latest cipher suites, and things like not being vulnerable to the Heartbleed attack. In the case of F5, we had our own SSL stack, and that Heartbleed vulnerability was related to the OpenSSL stack. So yeah, you all want to get an A. I use a toll road. I live in Orange County in California. They charge me a grip of cash every time I go down the toll road, but I have to put my credit card in their website. So before I knew it was illegal, I tested it, and it got like a C or something like that. C minus, I don't know. Somebody told me. No. Yeah, actually, somebody else had been doing it as well, and they were told that it was illegal. Again, you have to seek permission because they poke and prod at the SSL, so it might look malicious. Yeah. So yeah, this is Qualys Labs. You can go out there, do a test. This is more exciting stuff. These are all the versions of our software, but we always try and stay up to date with the latest versions of SSL, right? So when SSL 1.3 comes out, we hope to have that out, support for that as quickly as possible. But things like, people are asking for things like elliptic curve cryptography. We have support for all those kinds of things. And then all of these capabilities like network HSMs I've mentioned, all different capabilities that allow you to achieve an A grade. So these are, if you want to achieve an A grade on a big IP, it's very simple, just do that. It's very easy to set up actually, but so yeah, this is the idea, right? So again, users on the outside coming in and users on the outside going out. People want to also more highly secure environments are looking at forward proxy architectures as well, whereby you would look at connections, non-mutually authenticated SSL connections on the inside going out, because people want to be able to look at what you're doing, right? So when you log into, you want to go on the internet and you're in a DoD network, it may put up a banner and saying, we're watching you. So we also have deployment models that support that type of, we call it an SSL inspection architecture, but it creates an air gap in the middle to be able to look at decrypted SSL connections, and to be able to send them out to arbitrary security devices. So if you wanted to put in the gap, in your decrypted gap, if you wanted to put in an IDS or a Gigamon or a firewall, and you wanted to be able to look at all of your decrypted connections with lots of different kinds of devices, F5 supports that kind of architecture as well. We got our support in the reverse proxy. We got our start in the reverse proxy kind of model, but we also can now deploy in a forward proxy type of architecture. We can also install a categories database on there to be able to look at the types of things. So if you start looking at adult content, for instance, we can block and log you. So the whole idea, right, is that we're a full proxy. So we've got separate connections. The client talks to the big IP and it knows nothing about the application that it's talking to. And the big IP talks on behalf of the client to the application itself. So in that way, we can achieve this kind of full proxy architecture, which allows you to have completely separate connections on the left versus on the right. And in the middle, you can do some exciting things with the decrypted traffic. It's really kind of a simple concept, but there's kind of a lot of different details around there towards configuring it. There you go. In the gap, it's unencrypted. We also, you don't have to offload SSL to the back end, so you might just do SSL from the client to the big IP and then clear text from the big IP to the application. Just depends upon your security posture. For the most part, I see more secure environments doing SSL in as well as SSL out, but they might downgrade the SSL in the data center because it reduces the overhead on the servers themselves. It's a full proxy. We write our own operating system. In many cases, we can actually speed up the connections because we've got our own customized TCP stacks on the client side and a customized TCP stack on the server side. That allows us to have, and we do other things like HTTP compression and caching that can help speed up the connection. So people say, yeah, it's another hop. It's going to be slow, but for the most part, when you put it in, because you're optimizing so many different things, you can speed up the connections of the server. You can also monitor those back-end applications and send the connections to the best performing parts of the application. You can do some really, really nice things with respect to that. All right, so this is kind of what I'm talking about. Like, you have 50 applications, right? So say you've got 6 different applications, and they all have their own SSL capability. So if you have a vulnerability, you're going to have to go to 5 different places. You're going to have to seek different approvals for different applications. The whole idea behind this is you can do it in one place, right? So just if you implement SSL best practices on the big IP, it's very quick to deploy, and you're not doing things 5 times over. All right. I've kind of mentioned these, but in the gap, you can do all of these things, right? So we have all kinds of different. We have secure web gateway that gives you that categories database where you can look at the traffic and say, okay, don't want you looking at Nazi websites. Block you and log you. Send an email to your administrator. We can do things like, again, send decrypted traffic out to third-party devices, because we want to support a security device agnostic architecture where we can create either a layer 3, a layer 2, or a layer 3 type of decrypted connection. So we can send out to, say, something like an IDS, and in the case of layer 2, or a Gigamon, something like that, or say it's a Palo Alto firewall in the middle as well. They work they work best when you send them decrypted traffic. You can also turn on SSL on Palo Alto as well, but it will affect the performance of the firewall. So we're trying to build an agnostic solution where we will integrate with all of the other inspection devices. Again, this is for kind of outbound SSL inspection. Inbound as well, with the things like the web application firewall, where you're able to detect all different kinds of attacks with the decrypted content. We've got a box to fit your needs. Yeah, sure. Yeah, so, I mean, in this picture we've just got one, but we can scale. We've got something called scale-in, so you can build clusters of big IP devices with traffic groups, so that if you could send some of your traffic to some big IPs and some of your traffic to other big IPs, if one of those big IPs failed, the traffic group would switch over to an active device. And you can run these with in active standby types of configurations. For the most part, we see people still deploying in an active standby type of configuration. So yeah, we've done our homework around failover. So yeah, one size doesn't fit all. So we can do everything from, you can buy a big IP for $95 if you want to test it out with a credit card, all the way up to a Viprion, and you better have a big credit limit for that one. But so specifically the 10,200 there, that has a FIPS box that has a FIPS card on it. The 5250 has a FIPS card on it, and also the 7200 has a FIPS card on it. But you can take with these Viprions up there, that's an 8-blade rack-mounted box that has 3/4 of a terabit of second per throughput. I don't ever think it's really a conversation about throughput. It's about application functionality and all the different things that we can do with applications. But the basic platforms are very, very powerful. But if you needed FIPS, then you could use any number of these 10,200s to replicate the capabilities of one of those 10,200s. Looks like a Viprion blade, basically. So we can help you on the inbound as well as the outbound. Makes sense, right? So maybe you're building a security stack. That would be where you're building a forward proxy type of an architecture where you can inspect the user's SSL connections going outbound. And then traditionally for application delivery, that would be the reverse proxy architecture. And protect your keys. Put them in the castle. And we have the castle built onto the big IP. But yeah, I mean, we're trying to be agnostic about that. There are these guys out there that are even building cloud HSM, so maybe you don't even want to invest in an HSM. A network HSM, like SafeNet, offer a cloud service where it's just a SafeNet box somewhere out there on the internet. You can create a secure relationship between a big IP and that box and store your keys out there. And we support all of the above, right? So even if it's just we have a technology called Secure Vault. So even if you don't have a FIPS card on the box, there is a technology called Secure Vault that will encrypt your keys on the hard drive. And we have white papers about Secure Vault. So yeah, we support all of the above with respect to that. And that's kind of how it works. Big IP applications, but you've got the network HSM out there with all your keys on it. And then all of your key management capabilities. We also support the ability to do SSL offload from one big IP to another. So say you were deploying virtual editions, right? And you're worried about SSL performance on virtual editions, well, you can actually offload your SSL to another big IP from the virtual machine to another big IP. But if you look at it, you've got, again, applications on the left-hand side and then, users on the left-hand side and then applications on the right. And we're giving you all of these capabilities. So SSL re-encryption, encryption, re-encryption, web application firewall, the ability to do SSL inspection outbound as well. Cheaper. So, kind of in summary, it's not that simple. You know, SSL isn't that simple. You just can't press a button and turn it on. You need to deploy SSL kind of according to best practices. We have guides that will allow you to do that. We also have guides that will allow you to set up configurations for forward proxy architectures as well, right? So you can download guides. The basic SSL profiles, as the recommendations come out, the basic SSL profiles are all configured to support kind of the best-in-class or best practices SSL types of connections, and it's fairly simple to set up on a big IP. This is what Gartner say. I just say, look, get the document, get a big IP, and turn it on, and it's very simple to implement. Kind of an overview of Heartbleed as well as perfect forward secrecy, but I've kind of covered that. But that's kind of the bulk of the talk. Do you guys have any questions for me? Are you excited? Have you had your Red Bull yet? Okay. Thank you very much.